All right, we are now on to chapter 4. So here's the first lesson on chapter 4. This whole chapter is about triangles. And let's see, yep, they call it congruent triangles. We're not going to really talk about congruent triangles today. Another day we will. We'll talk a whole lot about it. But right now we're just going to talk about this, classifying triangles. We've discussed already what a triangle is. It's a polygon with 3 sides. It means it's a closed figure and all that kind of stuff. So I just happen to have a triangle right here. And let's start off. We're not going to classify them just yet. We will in a second. But let's start off talking about the different parts of a triangle and how to name the triangle, how to label it, just like we've done with line segments and lines and all that kind of stuff. So first thing we do, if you look at this, these are all 3 line segments, so they must have points on them. So we'll just call this, let's see, ABC. All right, so I'll call this triangle ABC, and we have a little symbol for triangle, and guess what it looks like? You guessed it. It's a triangle. So it's just a regular looking triangle, and we would call it triangle ABC. So what we're going to do is use the 3 vertices. There's 3 vertices on this triangle. We're going to use all 3 of those points to name the triangle, and it does not matter what order you put them in. It doesn't matter where you start, where you end. Just use those 3 points in any order. So it doesn't have to be triangle ABC. It could be, what else? ACB, BCA, BAC, whatever I left out. All right, you get the idea. So we call that a triangle ABC, and that's your symbol, just a little triangle. That kind of makes sense. So now let's talk about some of these parts of the triangle. So let's talk about the line segments themselves. The line segments themselves would be called the sides of the triangle, and they are line segments. So this side of the triangle will be line segment AB. This would be line segment BC. This is line segment AC. So those are the 3 sides of the triangle. So if I asked you to label the sides of the triangle, there would be 3 of them, and you would just name them, putting the line segment over top of it. All right, these points come into play right here. These are the vertices, okay, or it's plural for vertex. All right, so there's one vertex. This is one vertex, but the plural would be vertices. So it has 3 vertices. This would be one vertex. This would be another vertex, but all 3 are vertices, and they're just points. It's also made up of angles. We've talked about angles, and so let's take a look at this point right here. This would be angle A. You could also use 3 letters to name this angle. If I was going to name this angle right here, I could just say angle A, and that would be perfectly fine. Tell you what, let's do that in a different color. So we could call it angle A. I'll just put an arrow. Okay, so that angle right there is angle A. Or I could call it angle BAC or angle CAB. And again, we've discussed that before. So the triangle has 3 sides. It has 3 angles. It's got 3 vertices. And this would be angle C, obviously, and this right here would be angle B. Again, you could call angle B ABC or CBA. You could call angle C ACB or BCA. It doesn't matter as long as there's no other angles coming out of it. Okay, if that's the only angle at that vertex, then we could just call it angle A. Now, there will be some situations where we have maybe another line out like this, and I would have to use all 3 letters to represent angle B. But in this situation, we can just call it angle B. All right, now we're going to talk about classifying these different triangles. We're going to classify them. We're going to classify these triangles 2 different ways. Okay, the first way, just put a 1 right here. We're going to classify them. Okay, the triangle. And whenever I have triangle, I could always put the symbol instead of writing out the word triangle. So I could class the triangle by its angles. All right, so this is the first way that I'm going to classify them. The second way would be by its sides, but let's just right now just do it by the angles. So we're going to classify the triangle by its angles. So what we're going to do is we're going to look at the triangle, look at the angles, and say, oh, this is this type of triangle. That's what we mean by classify them. Tell me what type of triangle it actually is. All right, so here's this triangle. Looks just like the triangle before, and we want to classify this triangle. I don't even think I need to label it. Let's just talk about the angles. Again, I'm classifying it by the angles, so I want to look at the angles of this triangle and see what type of angles they are. Look at this angle right here, this one here. This one right here. All three of those angles, what kind of angles do these three look like? And we've talked about the different types of angles. Hopefully, you said that they were acute angles. All right, they are acute angles, which means they are less than 90 degrees. So all three of these angles are acute angles. So if all three, let's write it down, all three are acute angles on this triangle, we would call this, guess what we'll call it? It's not much of a stretch. We're going to call it an acute triangle. All right, that's when all three angles are acute angles. Now, there are some triangles where a couple of the angles are acute, but it's not an acute angle or a triangle. They all three have to be acute angles, and I would call this an acute triangle. So this triangle right here is an acute triangle. Let's take a look at this triangle, and you say, well, wait a minute, this looks kind of like the other one. It's not quite as slanted as the other one, but it looks like you have all three acute angles, and you're absolutely right. You could call this an acute triangle. But let's get a little bit more specific. Now, if I had a protractor, I could sit here and I could measure these three angles. But I'll tell you right now, I made this special so this would work. That this angle, this one, and this one, all three of them, okay, they're not just acute angles, but a little bit more specific, okay? They are all congruent angles, right? So if I have all three congruent, or you could just say equal. I'm fine with if you say that. Congruent or equal angles. So when all three are actually equal to each other, when all three are exactly the same, we call this an equiangular. Equa meaning equal, and then angular, of course, that means the angles. So we call this an equiangular triangle. We're going to learn a little bit more about a equiangular triangle a little bit, but if I know that all three of these angles are equal to each other, and how do I know it? Do I just look and say, well, they sure look like they're equal to each other? No, I have to be told, all right? You could just put the arcs in here, that's enough. You don't have to know what those angles are, but if they put the arcs in there, you know it's equiangular. And again, we'll talk a little bit more about that a little bit later as far as how many degrees and all that kind of stuff that the angles are. But for right now, I just need you to know that's an equiangular triangle. Let's look at another type. All right, look at this crazy looking triangle. Well, if you look at this, remember we talked about acute angles? It has a couple acute angles, but is this an acute triangle? No, all three would have to be acute. All three angles would have to be acute if we're going to call this an acute triangle. Look at this angle right here. This angle right there definitely does not look acute. It looks more than 90 degrees, and that looks like an obtuse angle. So if you have a triangle that has just one, I'll just put a 1 right there, one obtuse angle, we call that, what do you think? Yeah, again, it's not brain surgery here. Okay, they name it the way you think they should name it. This is called an obtuse triangle. So this is an obtuse triangle if it only has one, this is a 1, if it only has one obtuse angle, it's an obtuse triangle. We're going to learn in the next lesson that you can't have a triangle with any more than one obtuse angle in it. All right, so you can only have at the most one obtuse angle inside of a triangle. Now the other two are acute, and that's perfectly fine. But if it has one obtuse angle, we call this triangle an obtuse triangle. All right, here's the last one that we're going to do, classifying them by the angles. So if you take a look at this, again, it looks like you got an acute here and acute here, and it sure looks like this is a right angle. It looks like it's 90 degrees. Now, if I didn't mark it, you could not assume that it's 90 degrees. Make sure you don't do that. A lot of people do that. They say, oh, that looks like it's 90 degrees, so it must be a right angle. Well, you can't say that, but what if they tell you that it's 90 degrees? And they can do that several different ways. One way is just put a little box right there. If they put a box here, that means that this is a right angle. So guess what? If you have one right angle, okay, no more, okay, you can't have any more. Well, again, we're going to learn that tomorrow, or well, the next lesson. You can't have any more than one right angle, just like the obtuse. So if you have one right angle, we call this triangle a right triangle. Even though these two angles right here are acute, we still call this a right triangle because of that one right angle right there. So that's a right triangle. In fact, we have a whole entire chapter, I forget what chapter it is, but we have a whole entire chapter that is just on right triangles. It's hard to believe that you can have that much information about a right triangle that fills up a whole chapter. But we do, and we'll get to it eventually. Let's now talk about classifying angles by its sides. Before I change my mind, before we go on to the classifying by the sides, let's do this example really quick. It says classified triangle PQR. PQR is the whole big triangle, PQR. So I'm looking at that whole entire big triangle right here. We want to classify it by its angles. Well, let's see. They actually put some measurements in there, some numbers in there to find what the angles are. That's 45, so that's an acute. 31, that's an acute. Now, if I do PQR, I got to look at that whole entire angle Q, which is from here to here. So I have to look at that whole angle. Well, it's split up into two different angles, so in order to figure out what the whole thing is, I'm going to have to add them up. So let's see, that's 9 and 5 is 14, carry the 1, that's a 9 and 104, right? So that would be 104 degrees, angle Q. So what kind of an angle is 104 degrees? Well, that's an obtuse angle. Remember, if you only have one obtuse angle, it has to be an obtuse triangle. So I would call this an obtuse triangle. Now, they don't ask you this on the in the book, but what if I was to ask you classify triangle, let's just write it down here, triangle QSR, QSR, and I asked you to tell me what kind of triangle that is by its angles, okay, classified by its angles. Well, here's Q, here's S, here's R, 59, 31, and this. What is this? That's 90. So that must be a 90-degree angle, a right angle, so angle QSR would be a right triangle. Pretty simple. All right. What would triangle PQS be? PQS. Well, we got a 45, a 45. Doesn't have anything marked here. Well, if this is a right angle, then this has to be a right angle as well because they're supplementary, forms a linear pair. So that's a right triangle as well. So that triangle would also be a right triangle. Now what we're going to do is we are going to classify, let's write it down. We're going to classify these triangles, not by its angles this time. Classify the triangles by, or classify the triangle by its sides. Tell you what, I went all caps on the angles before, so let's go all caps here just to emphasize it a little bit. All right, so we are going to classify the triangle. Let's get that apostrophe S out of there. Classify the triangle by its sides. So let's take a look at this triangle right here. It kind of looks like another triangle that we've discussed already. It kind of looks like that equiangular triangle. But this time, they tell you this. Remember what the tick marks are? The tick marks mean that all three of those line segments are equal to each other. So if I have, remember, we're classifying it by its sides now. I'm not looking at the angles this time. I'm looking at the sides and seeing what they have in common. So if I classify by its sides, and if I told you that these three sides are equal to each other, it wouldn't be called, we wouldn't necessarily call it equiangular because we're classifying it by its sides. We would call it and then you would think sidular or something. No, that wouldn't be a right word. We call it equilateral. Equilateral, if I can spell it right. Lateral means sides, okay? Lateral. If you ever played sports or something like a basketball drill, you move laterally, you move side to side, okay? So lateral means side. So if it has equal sides, then that triangle would be called equilateral. We're going to talk about this. I don't think they discuss it in this lesson, but we'll probably talk about it later on, that you're going to find out that an equilateral triangle is also equiangular, and we'll see that in another lesson, but that's just a little bit of a heads up for you later on, okay? If it's equilateral, it will be equiangular as well. Okay, look at this triangle. That looks pretty crazy. It's definitely not lateral because those two sides look way bigger than this side right here, so there's no way that that's true. But if I was to measure this side right here and this side right here, I would find out that they would be the same length, okay? So if they told me, I can't just guess that they are, okay, but let's just say they told me. I actually did, when I made this triangle, I made it so those two lengths are exactly the same. So if you have a triangle with two legs, we call these the legs of the triangle, or the sides, let's say that, the two sides of the triangle, if they're equal, only two, okay? If you have two sides equal to each other, We give this a crazy name. Now, this is not one of those names where you can kind of like figure out on your own probably, but it's called isosceles. Notice how I spell this. Isos and then Celes. Isosceles, kind of like Celine Dion. That's how we do that. All right, so isosceles, and we call this an isosceles triangles. Pretty weird word. I forget where it comes from. I'm not going to look it up right now, but you could always look it up where isosceles comes from. All right, it means something. It's broken down into two things, into two different words. It's like Greek or Latin or something. I'm not really sure, but I'm sure that you don't care that much anyway. But it's called an isosceles triangle. When is an isosceles? It's isosceles if two of the sides are equal to each other. Now, technically, the definition says at least two of the sides are equal to each other. So you could have two or more. So if you go back to that equilateral triangle, is this at least two of the sides are equal? Absolutely. All right, so technically I could call this isosceles as well, but normally we don't. Normally if all three are equal to each other, we just stick with equilateral. But if only two sides are equal, we usually stick with the word isosceles, even though technically the definition includes if you have three sides equal to each other. But if two sides are equal, then it's an isosceles triangle. And we're going to do a lot of stuff later on, and you need to know if it's an isosceles triangle, and we're going to do a lot of stuff with isosceles triangles later on. But right now, it's real basic. All right, this is the last triangle we're going to talk about, and it looks like a triangle that we've discussed before. It looks like that's an obtuse angle right here, and these are both acute, so we call it an obtuse triangle. But remember what we're doing. We're classifying by its sides, not by its angle. So I got to look at the lengths of these sides. Notice, nothing is marked, okay? I haven't marked anything. Or if I wanted to, I could say this is 3, this is 5, and let's say this is 7, okay? So what if I had a triangle and I had these? Notice, are any of the sides equal to each other? No, they're not. So if none of the sides, no sides are equal. So if none of the sides are equal or congruent to each other, here's another crazy word. We call it a scalene triangle. I've never looked that up, so I'm not sure where that came from, but we call it a scalene triangle. There's really not much to know about scalene triangles. We don't really have any theorems or any rules or anything like that. It's just nice to know if none of the sides are equal, we call it a scalene triangle. Okay, we've got a couple examples we're going to do. Let's take a look at this one. Here's the picture and here's the question. It says if point M, right here, is the midpoint of line segment JL. So here's JL. Now point M is the midpoint. So the midpoint means it splits that segment into two equal parts. So before we even read on, take a look. I've already got one tick mark right here and one right here. Well, if M is the midpoint, that must mean that LM and JM must be equal to each other if this is the midpoint. So if that's the midpoint, it's halfway in between, which means these two segments are going to equal each other. So I could put a tick mark right there as well, since I know that M is the midpoint. So that's really important. If M is a midpoint, then let's read on. It says classified triangle JKM. Let's find JKM. JKM. It's this one. All right, I'll just kind of shade it in a little bit, just so you know which one we're talking about. So we want to classify that as equilateral, which means what? All three sides are equal. Or if it's isosceles, which means two of the sides are equal. Or if it's scalene, which means none of the sides are equal. And it says to, I didn't write it down, but it says to explain your reasons. So if you take a look, what do we know about the sides of this triangle right here? Well, we know we have a tick mark here, and we have a tick mark right here. So that means that these two sides are equal to each other. So which one of these means that two of the sides are equal? Well, that means isosceles. We can't say equilateral because all three have to be true. Scalene means none of the sides are equal. Isosceles means two of the sides are equal. So I would say that it would be isosceles because these two sides, because JK equals JM, not JK, I'm sorry, KM equals JM, they're equal to each other. That would be your reason, and thus it's isosceles. All right, here's the last example that we're going to do, and we'll be finished after we finish this problem. It says find the measures of the sides. Which sides? Well, if it just says the sides, that means all three of them. So I have to find all three sides of this isosceles triangle ABC. So here's triangle ABC. How do I know it's isosceles? Well, because of this, oopsie daisy, sorry about that. Because of this and this. right? Those two tick marks mean it's isosceles, which means I should be able to figure out what I can do with those two sides. If they're equal to each other, I'm actually going to set this and this equal to each other. So let's go ahead and do that. I always like to put the larger number on the left, so I'm going to go 5x minus, it's a half, or 0.5, equals 4x plus 1. Subtract 4x from both sides. Let's make that a little bit thicker. Subtract 4x from both sides, I get x. Add a half to both sides, and I get 1.5, or just 1.5. Or, I know you guys hate this, but there's a reason. This could be helpful. I don't know. Maybe not, but we'll just, let's not use that. Sorry. Let's just do this. Okay, x is 1.5. Is that what we're trying to do? Well, that's part of what we want to do, but we want to find the lengths of all three sides. So I have to find this side, I got to find this side, and I got to find that side right there. So I got to find all three of them. Doesn't matter which one you do first, but we're going to use this. This is not our answer, but we're going to use this to plug in, okay? Plug and chug. So let's do this one first, AC. So it's going to be 4 times x, which is 1.5, and then plus 1. And let's see, if you do that, you get, this is 6 plus 1 is 7. And so AC, we'll write it like this. The length of AC, notice I didn't put a line segment over top of it, because when you don't do that, when you don't put a line segment over top of it, it means the length of. What is the length of line segment AC? Well, it's 7. Let's do this one right here. And we're going to plug in x for this. So we're going to go 5 times 1.5 and then minus 0.5, or a half. So let's see what that's going to be. You know what? I'm thinking about this. Why even bother doing this? You could, because that would be 7.5 minus a half, which is 7. But look, you don't even have to bother doing that. Why? Because this was already marked equal to this. I don't even have to bother doing the math. So if AC is 7, then what's BC going to be without doing any math at all? It should be 7. And it will work out that way, but that's the best way to do it. I practically did that whole problem until I realized, oh, there's a lot better way to do this. So BC is also 7 without doing any math at all. And then we do one more. Let's find AB, and that would be 9 times x, which is 1.5, and then minus 1. And let's see, that's 13.5 if you do that, minus 1, which is 12.5. And that would be AB. So I'm going to put AB right here, and we'll circle that as well. So those are my answers. So this right here is 12.5, and this is 7, and this is 7, and that's all you need to do. All right, that's it for classifying triangles. That's a good start.